Okay, so we've got a question on braking and kinetic energy, cars slowing down and the energy they need to use to do that. So, first question is asking about stopping distance of a vehicle. It's made up of two parts. It's made up of the thinking distance and the braking distance. So what is meant by thinking distance? There's a very common mistake made by people when they're looking at the stopping distance questions. They immediately start talking about time and reaction time and things like that. And this is asking about thinking distance. So we're not asking about the time, we're asking about a distance. So what is thinking distance? Thinking distance is a distance. It's the distance that a car moves as the driver reacts. So, yeah, it's the car is moving forward. Somebody steps out, a cat runs across the road, and it's how far that car travels from the point the driver realizes that they want to stop to the point that they're actually applying the brakes. Okay. State two factors that affect thinking distance. Now this is something to do with your reaction time. It's going to be things that affect your reaction time. If something slows down your reaction time, that's going to increase the thinking distance. So the obvious ones, stuff to do with drugs and alcohol. Also tiredness would be acceptable, but not something that's going to block your vision. If you're driving and it's misty or it's foggy, then yes, you are more likely to have an accident because you can't see something coming. But that's not affecting the thinking distance because, as I said before, it's measured at the point the driver realizes they want to stop. And so the fact that they don't realize they want to stop because it's misty or foggy isn't taken into account in the thinking distance. Okay, so now we've got the car is travelling along a speed of 20 meters per second when the driver applies the brakes. The car decelerates at a constant rate and stops, so it's going from 20 seconds to 0. We've got a nice units of kilograms and meters per second. Mass of the car is 1,600 kilograms. Calculate the kinetic energy of the car. Okay, so we need to know the equation for kinetic energy. Kinetic energy, you need to know is half the mass times the velocity squared. So we put our numbers into here. What's the argument? It's given by 1,600. So we can say half of 1,600 times by velocity is 20 seconds. So times by 20, that's squared, remember. So we need to times by 20 again. So some people will quite often just half the mass straight off. So that's going to be 800 and 20 times 20 is 400. You pop that into your calculator, you find that the kinetic energy is 320,000 joules. Right, and then this next question looks very difficult. How much work is done by the braking force to stop the car and the driver? Oh, it doesn't seem to say. It tells us the kinetic energy the car's got, but it doesn't say anything about work done. And people will be looking at it and saying, well, I can remember the equation. Work is force times distance, but I don't know the distance, and I don't know that. And actually, they're getting themselves in a bit of a bother over nothing because actually, you've already worked out the answer. If our car has 320,000 joules of energy as it's travelling, then that tells us that it will take 320,000 joules of energy to stop. That's the work that the brakes will need to do. So the answer is already given. And if you look, the clue's actually in the question, because they've given you no room at all to work it out. They're just asking straight away for the answer. So they're kind of giving you a clue that you've got the answer already. So the answer is 3. that's the kinetic energy you have at the start. That's the kinetic energy, that's the work that will need to be done to use up that kinetic energy, to transfer that kinetic energy. So the braking force is used to stop the car and the driver, and you've got a force of 8,000 newtons, calculating the braking distance of the car. And actually now this comes back to that work equation. So the work done by the brakes is equal to the force of the brakes times by the distance the car travels. Well, we're working out the distance, so we need to rearrange this, divide both sides by the force, and we get the distance is going to be the work over the force. The work we know from up here, as the work done, so that's 320,000 joules divided by the force. There we go, gives us the force. That's 8,000 joules, 8,000 newtons. Again, we pop that into the calculator and it just comes up with a nice round even 40 meters. So the car will go 40 meters. And you, again, I think in instances like this, you'd stop yourself and think, is that a reasonable distance for a car to stop? Yes, 40 meters. It's not like we're looking at 40 miles or 40 millimeters, so that's reasonable. Okay, the braking distance of a car depends on the speed of the car and the braking force applied. Stated one other factor that affects braking distance. So, what is braking distance? It's how far the car travels while the brakes are applied. So again, it's not going to be affected by whether the driver's had a drink or has taken too many aspirin or whatever. It's a case of actually just the tyres on the road and what affects those. So we're looking at surface conditions. So is the road wet? Is there ice on the road? Are the tyres worn? Are the brakes worn? Anything that affects that friction between the tyres and the road. Okay, and then finally, applying the brakes to the car causes the temperature of the brakes to increase. Why? Well, one easy mark is friction. I think for the second half, then we have to explain a little bit more about what that means, what's going on. In terms of friction, we know that the kinetic energy of the brakes distance is going down, and that is being converted into thermal energy, into heat. So that's the shortest. A decent length question on braking distance, thinking distance. Key points really to remember. Total stopping distance is the whole thing, but it's made up of how far the car goes as the driver is reacting, taking his foot or her foot off the accelerator and just getting it across to start to press the brakes. And then our braking distance is then how far the car goes at the point the brakes are applied until where the car stops.